Hello, let's make an origami paper cup and then do some gentle mathematical reflection, and after that we are going to try it again using a different approach. The origami paper cup is one of the simplest projects out there. Starting from a square, we can quickly fold it into a functional paper cup. You can use it for multiple purposes. Let's give it a try. Here I have a square, a typical type of origami paper, measuring 6 inches by 6 inches, as you can see. All right. The square has 2 diagonals. Let's fold the square along one of its diagonals. Fold it carefully and try your best to be accurate. Now we have a triangle, and isosceles is a right triangle if you want to be specific. And this triangle has 2 corners at the bottom. Okay, the way I hold it right now, there's the right angle. Here we have 2 corners at the bottom. We're going to start with one of them. How about the lower right one? We're going to fold this corner, vertex, to the other side, to the left side. Okay, fold it in a way so that the upper line there is parallel to the bottom line. Just move the corner up and down. Estimate. All right, when you're happy, when you think the upper line is parallel to the bottom, press it hard, making a crease like that. And that point is very important. Let's put a mark there. This point. And of course we have another corner. We're going to flip the triangle like that and fold. Again, we have the lower right corner. Fold it to the left side, and you can use the point you made a moment ago. If you did everything accurately, the top line here is also parallel to the bottom. Press it and make a crease like that. Now we have a pentagon, looking like a cupcake. Pick it up, take a closer look. At the very top we have 2 triangles, okay, 2 flaps. At the front we have a pocket. In the back we also have a pocket. Next we are going to fold these 2 flaps into the pockets. Okay, starting, how about from the front one? Okay, take the triangle and push it in. Try to open a little like that. Push the triangle in. Open it. Push it in and go as far as you can. Okay, and then squeeze it a little bit. And of course, if you like it, you can first fold the triangle, fold it all the way down and make that crease. Now we have a second pocket in the back. Open it and push the triangle inside. Go as far as you can. You tuck it in, okay? All right. And adjust it as necessary, okay, until you're happy with this shape. Now we have a trapezoid, right? At the top of the trapezoid, and we have an opening. Put your fingers inside and open it. So we have a cup. You can pour water in it and drink from it if you want to. Unless it's waterproof and it's a one-time use. If you like, you can also flatten the bottom a little bit and try to make it stand on the table. It's pretty hard. There are some interesting questions that you can ask about this cup. What's the volume of this cup if the square is a 6-inch one? Well, you can actually estimate this volume using pinto beans, as I have here, or rice, if you have a lot of patience to count the number of grains. If you make this paper cup from a 6-inch square, according to my experience, you can put about 60 pinto beans inside. It's an interesting project. Can dump all the pinto beans on the table and count them one by one, and there are certainly many ways to count it. Anyway, review a little bit. This is essentially what we did. We started with a square, right? We fold the square along a diagonal, and we got a triangle, and then we fold the bottom corners of the triangle to the left and the right. At the same time, we made sure that the upper horizontal line is parallel to the bottom, and we did it to both sides for a cupcake shape. And then we folded the top two triangles into the two pockets, and we made a cup. Now, if you open the cup, you are going to see what you did to the square. This is essentially what you did. We folded the right corner C, okay, to the point E. Well, we don't have E in the beginning, and we use the idea of parallel lines. Now, if you were to find this point E mathematically, how can you do that? In other words, if you look at the picture, what's the nature of this segment from C to E? Well, this CE, the segment, is essential for us to find the point E if we do not use, well, parallel lines, or if we do not want to estimate. It turns out, because the way we folded C to E, these two segments, FC, okay, and EF, they are the same, right? You folded C to E, and FC, therefore, is the same as, or has the same length as EF. And also because EF is parallel, or supposed to be parallel to the bottom of AC, the diagonal here, so this angle here, okay, must be the same as this one. Why? EF is parallel to HC or AC, or the bottom diagonal. So therefore, this angle here is equal to this one. Okay. Alternate interior angles, and because EF and FC are the same or congruent, so this angle here must be the same as this angle here. So all these three angles have to be the same. Therefore, this angle, this segment EC is the angle bisector of what? Of this angle here. It's a 45-degree angle. So in other words, if we do not want to use the idea behind parallel lines, we can find the angle bisector of this angle. That way we can find this point E. Okay, that's a mathematical insight. Does that make sense? So through our gentle analysis, we learned that we can find that point E using an angle bisector. Let's do that and see how it works. Alright, I'm going to get another square. How about this one? This time I'm going to say, well, let's fold it along one of the diagonals first, like that. Let's change our wording. This time I'm going to say, I'm not going to say fold this corner to the left. I'm going to say fold one of these, or bisect one of these angles. Okay? We're going to say fold. How do you do that? We're going to fold this side to the bottom, or the bottom to that side. You can fold it this way, or you can fold that side down. It doesn't matter. And we do numerous folds like that in making origami objects. Does that make sense? Okay, so we're going to fold the bottom side to the right edge like that. Okay, make sure you align them well and make a crease. That point there is the colored point we're looking for. Let me put a dot there. Does that make sense? Alright, now you can say I'm going to fold this corner directly to that blue point. Okay, flatten it. And if you are accurate, the upper horizontal line is guaranteed to be parallel to the bottom. All right. Well, we already have the other point. If you so insist on finding that point, you can bisect the other angle, folding the bottom side to the left side like that. Okay. As you can see, they all match. Let me put a point there. Alright, of course, we are going to fold one to the front, the other one to the back. Alright, so that's how we can drop the parallel lines and focus on using angle bisectors. Well, there are many ways to make origami objects. Okay, just be flexible. Now, we're going to tuck this in. Okay, take your time and push it all the way in. And we have a second one. Push it in all the way down to the inside and flatten it. We have a cup made in a slightly different way. Does that make sense? Alright, there are many other questions you can ask about this paper cup. How about this? Alright, this is a 6-inch square, as you can see. What if I divide it into 4 3-inch squares, like this one? Okay, this is a 3-inch square. And I can fold this into a paper cup in the same way. Kind of hard to manipulate now. Let's try. Either way, parallel lines fine. Angle bisector also fine, since we know both methods are equivalent at this moment. Alright. I've had children making these baby cups before, tucked in. Well, they can do a better job than me because their fingers are tiny. You can use a pen if you want to, like get a pen and push it open like that, and then tuck the triangle inside. Okay, we have a baby cup. Still works. Question: if this big one can hold, let's say 64 pinto beans, how many pinto beans do you think you can put in this little one? Well, the squares, they are two-dimensional ideas, right? The volume is a three-dimensional idea. Well, you can do some experiments using pinto beans, real pinto beans, or you can use some mathematical reasoning. The little one can hold 1/8. Okay, 1/8 the volume of the big one. If the big one can hold 64 pinto beans, this little one can hold about 8 pinto beans. You can give it a try. Or you can use water. Okay, take 8 cups using the little one and see what happened to the big one. Of course, we're just estimating. Now, I don't have a square that, well, origami square that's 12 inches by 12 inches, but I do have a large one here. It's a PETG film, and it's 12 inches by 12 inches, as you can see. All right. Now, if I were to fold this into a paper cup, okay, like that, I'm not going to do it. What do you think is the volume of this big paper cup or PETG cup? Okay, this one is made out of a square that's 6 inches by 6 inches, and this blue square is 12 inches by 12 inches. If I were to fold this into a paper cup like this, that big paper cup can hold how many times as many pinto beans as this one? Again, the volume is a three-dimensional idea, right? So we would expect the big blue cup to hold 8 times as many as pinto beans as this one. So there are just many ways to play with these simple origami projects, and you can focus on the art or the cup, or you can ask some mathematical questions. Some mathematical questions can be really challenging, but in the context of paper cup, it's manageable and it's interesting, especially when you when you open the square and look at what you did to the square. Look at the folds. Okay, it's always interesting to open an origami project like this. It may be hard to open. Careful. Right. It's a piece of paper, and look at the consequence of your work. Do you see those? The trapezoids? Do you see the triangles? And we really don't have the angle bisector there, right? The angle bisector is a mathematical consequence. All right. As I said, you can estimate its volume using pinto beans or any grain you might have, or just use liquid. All right. That's all I have for the origami paper cut project. And stretch it and in the way you like. Thank you.